Okay, I'm going to go through one question from each section on the factoring notes in packet. So let's start with, so this is going to be section 1, which is factoring out the greatest common factor. So let's take a look. Let's actually do question 11, which is one of your homework questions if you didn't finish it in class. So question 11 is 2x cubed minus 3x squared plus 5x. All right, so I'm looking for a greatest common factor. So what I'm going to do, I'm going to draw parentheses around the entire thing, and I'm going to draw lines under each thing. And the reason I'm drawing those lines is because I'm going to be dividing each term by something. And the something is going to be the greatest common factor. So before I even start my problem, I like to do the parentheses and the lines. All right, let's look at my coefficients, 2, -3, and 5. Is there a greatest common factor between these numbers other than 1 in itself? Well, no, these are all prime numbers, right? Prime numbers are only divisible by 1 in itself. I can't divide, you really should be checking the small number, right? You're not going to be able to divide big numbers into everything. But if I check 2, I can't divide 5 by 2 and get an integer answer. I can't divide -3 by 2 and get an integer answer. I'm looking for something with no decimals, right? When I divide 5 divided by 2, I get 2.5. I don't want a decimal here. I'm looking for integers. Integers don't have any sort of decimal part to them. So that's it. I don't have anything other than 1. So let's look at my variables then. I have 3 x's, 2 x's, and 1 x. So when you're looking at your variables, you want the smallest, right? This is actually x to the 1. That's what you're looking at, your smallest exponent. That means I can divide each of these by x to the 1. So I write it under each one because I'm going to be dividing, and I write it out here too. And again, I can't divide by something I don't have. I have 2 x's here, so yeah, I could divide x to the 3rd by x squared, but I only have 1. So I definitely can't divide by 2 if I only have 1. So now I've got same, I can cross that off. So my answer is the x, the GCF on the outside. I didn't do anything with the number, so I still have a 2. X cubed divided by x is x squared. Again, my numbers, I'm not doing anything with those, that's still -3. X squared divided by x is x, and then we said x divided by x is 1, so I have plus 5. So on these kind of problems, if I start with 3 terms, which I did, this is my original problem. There's 1, 2, 3 terms, right? Terms are separated by pluses and minuses. I should have the same amount of terms inside my parentheses at the end, 1, 2, 3. And if I go back and I multiply this x by each, if I distribute, I should get the original problem. So that's section 1. Section 2, we have factoring by grouping. So let's take a look, maybe let's do one of the later ones here too. Let's look at number 13. So 13's problem is x cubed plus x squared minus x minus 1. All right, so to factor by grouping, I don't have a lot of numbers here, I just have letters. So I want to kind of get them in groups of 2 where I can say, okay, what can I divide into maybe this group of 2? Because there's not something, I can't do a GCF, right? A GCF means I have a number for all of these or a letter for all of these. So I don't have a coefficient really for anything except these 2, and it's just -1. And I don't have x for all my terms. This term doesn't have an x. So let's kind of split it up into these 2, right? And then we can split it up there and see what I can do. So if I split up here, and then I'm going to try here too. So I'm going to put a plus in between here. I don't want to make that look like a multiply. Let's see. I'll rewrite it. X plus x squared negative x minus 1. All right. Out of these, I can see I can take an x from both, right? They both have, actually I can take an x squared from both. So I'm going to divide each one by x squared, and I get x squared. X cubed divided by x squared is just x, and x squared divided by x squared is 1. For these 2, I can take out a -1. When I do that, -1 negative 1, negative 1. I have negative 1 divided by negative 1, which is positive. Negative 1 divided by negative 1 is positive. And the goal of grouping is that I should have the same thing in the parentheses at the end if it's able to be grouped. And I do. I have x plus 1. So then these two come together. I've got x squared minus 1, and then I have x plus 1. And we're going to stop right here. We could continue to factor this, but we're just doing grouping right now, so we're going to leave it alone. And if I go through and I do box method, I should come back to my original answer, or my original problem, which is, the original one was x cubed plus x squared minus x minus 1. All right, let's take a look at section 3. Section 3, let's do number 21. So 21 is 45 plus 14y plus y squared. And honestly, for me, I like to see it in standard form, which means my biggest exponent first. So I'm going to rewrite it just for me, because I would rather see it this way. So now, what I'm looking for is, this is the coefficient here is my a, this coefficient is my b, and this coefficient is my c. I need to know what a times c is, and I need to know what b is. So a times c, 1 times 45 is 45. B is 14. I am looking for two numbers that multiply to be a times c and add up to be b. If you have a hard time doing factors, you get in your calculator, go to y equals, put your number that you're looking for factors of, which in this case is 45, divided by x. Then go to your table, and your factors are going to be all of your ones that are not decimals. So for example, 1 and 45, those are factors. 2 and 22.5 are not, because that one has a decimal. 3 and 15 are factors. 5 and 9 are factors. So sometimes it's actually easier to look down here, because I can say, okay, 1 and 45, do those add up to 14? No. 3 and 15? No. 5 and 9? Yeah. So I have 5 times 9 equals 45. 5 plus 9 equals 14. So I'm good. Those are my numbers. So when I write it, I have two sets of parentheses. And I can do this because, so I could have drawn these before I even started. Because a is 1, the only way to get this y squared is to have a y and a y here. But then these are my two numbers. And be careful of the signs. This is positive 5 and positive 9. So it's plus 5 plus 9. And that is your answer. And if you go back and check it by box method, you should end up with this original problem. All right, let's try section 4. So we're moving on to section 4. Let's do number 19. So 19 is y squared minus 7xy plus 10x squared. All right, so again, my a is 1. This one looks a little more confusing because I've got an x squared here as well and an x there. But it's my same process. Let's look at the coefficients. So I need to know what a times c equals and what b is. So a is 1, c is 10. 1 times 10 is 10. B is negative 7. So my two numbers need to multiply to be AC and add up to be B. Again, if you have a hard time doing this, do it in your calculator. But at this point, you might see that I know 5 times 2 is 10. But 5 times 2 is not negative 7. So that's not going to work. Or 5 plus 2 is not negative 7. But think about, what if I had negative 5 and negative 2, right? Negative 5 times negative 2 is positive 10, which is what I want, because a negative times a negative is a positive. And negative 5 plus negative 2 is negative 7. So these check out. So make sure you are paying attention to your signs. Are really important. Now, when I do this, kind of like our other one, I'm going to have a y here and a y here. That x back there means it's got to end in an x. Now I'm going to deal with my numbers. And we said I have minus 5, and minus 2. That is my answer. If I check this and do box method and check it out, I will get this original problem. So let's actually do that one just so you guys can see. I have y and I have minus 5x. I have y and minus 2x. Y times y is y squared. These two, y times negative 2x, I have negative 2xy, right? These are not the same base, so I can't just add exponents. Here, negative 5, same thing, not the same base, so it just has to be xy. And then lastly here, negative 5 times negative 2 is positive 10, and x times x is x squared. I do a quick check and make sure these are like terms, and they are. So now I can take it out of the box. I have y squared, and if you get good at this, you can actually just combine these before you take it out. Like I've got negative 5xy, negative 2xy, I know they're like terms. That equals negative 7xy plus 10x squared, and this was my original problem, and this is what I got when I checked it. So I factored correctly.